Hello, welcome to Pasco Pathways Virtual Expo 2021. My name is Joseph Fernandez and I'm the robotics teacher here at Sun Lake. So this presentation is going to be about the robotics program here at Sun Lake. So first of all, what students would want to take this course? I guess is the first question that you may be asking. And the idea here is these students who are interested in science, technology, engineering, math, specifically robotics, and interested in pursuing a career in the STEM field, probably should be taking these robotics courses. I go over a lot of science, engineering, math, and technology, as well as robotics as a more defined subject through the courses. There's 4 courses in robotics here at Sun Lake. I understand that the STEM has become STEAM and has added an A for arts. And while we do some artistic type concepts here in robotics, I generally focus on science, technology, engineering, and math. This robotics program, and generally we refer to the robotics program of the 4 courses sometimes as an academy. This robotics program set of courses, this program is eligible for school choice. So if your student is not zoned for Sun Lake High School and they want to take robotics, they can use that to make them eligible for school choice to Sun Lake. Just want to tell you and show you that all applications would be submitted through my student for signing up for the courses in general, including the robotics, and the important dates to note for this open enrollment of school choice windows, since I just mentioned it, are shown here. So, who are we as Pasco County School District, as Pasco County Schools, as a Pasco County school teacher? What are we about? And what am I about, as well, I should say. So our mission, obviously, is to exist to provide a world-class education for all students. And so the idea here is we want students to achieve success in college, in their career, in life, whatever path they may choose. And we want to give them as many options of information for that, or education for that, I should say. So we want to get this idea of instructional excellence in our schools, and we want that to be done through success in schools by the students, by staff. We want staff efficacy and student achievement to increase, obviously. That's our goal. So that's our vision, right? Instructional excellence. So what are our common points in instructional excellence? What are we going to be doing? So as you can see on the screen, we're going to be thinking critically to understand and solve real-world problems. We want students to do that. We want them to collaborate and communicate, right, inside and outside their school community, utilize a variety of tools and resources to enhance their learning, build strong content knowledge, and be able to apply that learning to new contexts, and take ownership of their learning and reflect on their learning progress, which this says there. Okay, so you're here to hear about the robotics program here at Sun Lake, so I guess I should start talking about that. So what do we do here in robotics? We combine science, technology, engineering, and mathematics with computer programming to make a better and brighter future. So some of the things we do in robotics. We learn about the history of robotics from its very young, early stages all the way up to modern times. One of the big key issues in building, designing things is using the engineering design cycle. Just like there's a scientific method, there's an engineering design cycle. And the engineering design cycle allows you to figure out what a problem is and carefully come up with a solution, develop a solution, design a solution, build a solution, test a solution, and have that solution work on the problem that they found. We build robots. Plain and simple. An example of something you may be able to build here in our courses is the Vex robot on the bottom right-hand corner here. Also, we go over other robots that are built, which is what these other 2 are pictured. Go over how they're constructed, what factors they have, sensors, motors, servos, and so forth, so they can learn more about how they could build robots. And we do some of that as well in our courses, build robots other than just Rex robots for various different purposes. We also make robots do what we want them to do. So clearly a robot needs to be programmed, informed, or able to learn to accomplish the tasks that you want them to do, and we have to program them and build them and set them up and design them to do those things. And we can either use general computer programming, or we can even program them to be somewhat autonomous or even have artificial intelligence so that they can learn, deeply learn, if you will, learn how to do what they need to do. So a big thing we go over is mechanical engineering concepts such as drafting, physics related to robotics, including laws of motion, kinematics, simple machines, gears, mechanical properties, tolerance allowance, and a lot of other factors. Drafting in 2 dimensions, you see some examples here in drafting of 2 dimensions, or you can even do it in 3 dimensions. We use SolidWorks as our 3-dimensional modeling program. With that in mind, you can then do rapid prototyping, which falls more into engineering technology with 3D printing. We can also do virtual world analysis, build a virtual world, a virtual environment setup with our virtual robot to do motion and path planning, to do analysis on the effects of certain things in the environment or certain catastrophic failures that could occur and see how the robot would react, put obstacles in a way. We can affect the robot in certain ways, like apply water to it, or apply fire to it, or apply physical forces to it, contrary to what it would normally experience, to see how it could react in a virtual world before we design and construct it in the real world. Along with this, we learn more about collaboration, presentation, and writing techniques. Obviously, we've talked about programming, but we also looked at control systems and artificial intelligence, and using different programming languages such as Robot C, C++, Python, and much, much more. We delved a little bit more in mathematical analysis and modeling of certain characteristics related to robotics. Since we're dealing with circuitry and electronics, we clearly go into electrical engineering with electronics and circuits. And so we look at the idea here of learning how to solder, learning how to build circuit boards, electronic measurement and testing using appropriate tools such as multimeters and oscilloscopes, and so forth. So what happens in robotics? We do things, we learn things, and in the end we have fun. I said before that there are 4 different robotics courses, and they consist in a group of either robotics program or robotics academy, you can even refer to it as. And the 4 courses are the Foundation of Robotics, Robotic Design Essentials, Robotic Systems, and Robotic Application Capstone. Each of these courses is a year-long course taken as an elective by the student. And so the idea is they would do each year one of these courses, and then over the course of 4 years, they would complete all 4 courses. First course they would take, ideally, would be the Foundation of Robotics. Generally, this is offered to grades 9 through 12. Early on, we start doing a little bit of SolidWorks, but really the big focus on what you could actually have them do after the first year is obtain pre-engineering and robotic associate industrial certifications from RECF. Also, we're going to include a lot of materials I already talked about: history of robotics, laws of motion, basic electronics, simple machines. You can see the listing there as well: workplace safety using the OSHA safety course. They're going to learn more about teamwork and collaboration and so forth. Then we go on to Robotic Design Essentials. This is generally available for grades 10 through 12. Though if your child has taken the Foundation of Robotics course before high school, they obviously could go into this as a 9th grader as well. The idea is that they would have taken the Foundation of Robotics course prior to taking this course. Again, they can still get those pre-engineering and robotic associate industrial certifications. And we go into more advanced understanding of materials on electronics programming, including automation programming, more advanced 2D and 3D drafting. Here we get a lot more into SolidWorks as well, higher level engineering design, continue with the teamwork and collaboration, and much more advanced mechanical physics, including pneumatics and hydraulics, and even solenoids. And robotic systems, generally this is offered from grades 11 through 12. Ideally, they would have taken the Foundation of Robotics and Robotic Design Essential courses prior to this. Here is where they wrap up their SolidWorks understanding and learning, so they could take the SolidWorks, Certified SolidWorks Associate Industrial Certification exam and get their Certified SolidWorks Associate Industrial Certificate, which is, SolidWorks is a 3D modeling program used a lot in the industries, engineering, design, manufacturing, and industrial design and engineering as well. It's widely used, and it's really compatible to a lot of the other types of programs similar to it. So even if you weren't directly using SolidWorks, a lot of the similar programs like AutoCAD or Inventor, you get the basic skills out of this as well, so you can definitely apply that. Subjects obviously included are advanced control systems, advanced programming into the idea of artificial intelligence programming or automation, autonomous actions of automation, industrial manufacturing, engineering design, and again, we keep in the teamwork and collaboration as well, and more advanced topics. Lastly, we have the robotics application capstone. It's grade 12 generally because you should have taken the foundation of robotics, robotic design essentials, and robotic system courses prior to this. Here again, you can still get all these certification or take the certification tests offered previously in robotic systems. Now that we've gone over all the skills you need in robotics, this course focuses on taking a real-world problem and coming up with a real-world solution and using professional engineering skills in research, analysis, presentation, and reporting to do so. Look, heavy-level commercial, industrial, manufacturing, engineering, design, and analysis will be taught. A lot of different skills that they may not find anywhere else related to research, analysis, and presenting information in different ways will be covered as well. Different analysis that aren't normally covered in general mechanical engineering or electrical engineering. So ideally, they come out of this being able to come up with their own, come up with a product that solves a problem, and they've designed it and they can construct it and so forth. Here and in the prior course, robotic systems, students move away from a pre-set up VEX system into a more being able to take material, raw materials, or find base motors and sensors and so forth, and assemble them together, program it using programming languages such as Python or C++, and assemble a robot design that's functional and results in a solution to the problems they were trying to solve. You can see an example here of a design. This was a 3D model that was then turned into a 2D sketch so it could be presented. The idea here is you see the complete design. You see the wheels, you see the motors, you see the sensors, and the setup of it, including the structural setup, organized together all the parts. And the idea is that they can use this and then assemble in mass production their design. Well, thank you for joining me, and if you have any questions, there'll be a Q&A afterwards where I'll be there to answer questions about the program. Thank you very much.